All right, we're talking about trig today because trig kind of leads us into doing calculus with trig, but today is just periodic, it's just a review. I'm like getting ahead of myself reading this. So it's just a review. Hopefully this isn't too hard for you. Hopefully you remember these, but I'm happy to go through them a little slower in class if we need to. So first we're going to just talk about the graphs of the basic trig functions. So we've got sine, cosine, tangent, cosecant, secant, all of those. So remember that the values on these graphs come from the unit circle. So we're going to graph each value on the unit circle and then create a wave, because remember sine, cosine, all of these ones are periodic, which means like if I start the unit circle at 0, right, and I go around the unit circle, I get to 2 pi, and then if I kept going around, I would get to the same values again, right? It just creates a circle over and over. I could just keep going and I'd get, you know, sine equals 1, sine equals 0, sine equals 1, sine equals 0, sine equals -1, sine equals 0. You know, it would just keep going all the way around over and over. So it's periodic, so it just continues infinitely. So we're going to start with the sine. So remember, again, these come from the unit circle. So it's like we've taken a circle and we cut it and we just like flattened it out across the x-axis. So let's think about when x equals 0 on the unit circle, or not x, but when our angle equals 0 on the unit circle, what does sine equal? Well, that would be 0, right? Because that's that first point, you know, and remember that sine is our y value. And so then we think, okay, at pi, what is the sine equal? Sine is the y value, and at pi, that's equal to 1. And then, sorry, not at pi over 2. At pi over 2, sine is equal to 1, because that's halfway through, right? And then at pi, what's it equal to? Well, it's the y value, so it's back to 0. And then at pi, 3 pi over 2, it's back to -1. And then at 2 pi, it's back to 0. And since this is periodic, it's going to do the same thing. It's going to cycle, just like this, all the way through. So memorize these if you want, or if you have the unit circle memorized, you should be able to graph it. But this is definitely when you should be able to recognize, you should be able to graph, you should be able to transform. So just remember sine, you know, we a lot of times think about sine is the one that goes through the origin. And then cosine is a little different, remember, because cosine is the x value. So when we're looking at cosine, we're talking about what is the x value at each of these coordinates. Well, at 0, at our angle 0, the x value is equal to 1. And then at pi over 2, it's equal to 0. And then at pi, it's -1. And then so on and so forth. So it's, again, it's just this cycle, or this periodic motion, and it's just a wave. So cosine, instead of starting at the origin, goes through 0, 1. Okay, now cosecant. Cosecant is the reciprocal of sine, remember? So cosecant equals 1 over sine. So where would this be undefined? Hopefully you can figure out that that would be when sine equals 0, right? Because we can never divide by 0. So cosecant is undefined everywhere that sine is equal to 0, which means we're going to have asymptotes at 2 pi, at -2 pi, at pi. So everywhere that sine is equal to 0, we're going to have an asymptote because we can't divide by 0. In fact, when I'm graphing like a transformed cosecant graph, I actually graph the transformed sine graph and then use cosecant to find it. Okay, and so then we think about the reciprocals. So if we think about, say, like a point right here, right, say this is a y value of, say, 3/4, right? Well, what's the reciprocal of that? It'd be 4/3, so it'd be up here, right? And same here. All of these ones, if this one is like 1/3, what's the reciprocal of that? Well, that's 3, so it's going to go up here. So actually, cosecant is going to hit a min everywhere that sine hits a max, because it's the reciprocal. And again, I'm happy to like show these again slower. I just don't want to spend 10 videos doing these. So really I can explain every little bit of why that works if you want that. So Just know that. Okay, so cosecant looks like that. It's got asymptotes wherever sine is equal to 0. Secant is the reciprocal of cosine. Therefore, it's going to have asymptotes everywhere that cosine is equal to 0. So that would be at pi over 2, negative pi over 2. And again, since it's periodic, it's just going to keep doing that. And then it's going to have a max, a relative max, everywhere that cosine had a relative min. Because we're just doing the reciprocal. So secant looks like that. Okay, now tangent's a little different. Remember, tangent is sine over cosine. So we can figure out, where is this undefined? Where is tangent undefined? Well, it's everywhere that cosine is equal to 0. So if we go back to our cosine graph, where is cosine equal to 0? Well, it's equal to 0 here, here, at each of those. They changed the graph, the tick marks on the graph. Okay, so where's cosine equal to 0? At 3 pi over 2, and all of that, right? So we're going to come here, and cosine is equal to 0 at negative pi over 2, and positive pi over 2, and since 3 pi over 2 is not on this graph, we're not going to worry about it. And then think about, tangent is sine over cosine, right? So when sine and cosine are equal, and we know that happens at all the 45s, you know, at 45 and all that, when sine and cosine are equal, it's going to be equal to 1, right? Because it's the same thing divided by the same thing. So we know that, like right there, it's going to be equal to 1 when at pi over 4, which is 45, you know. And then at negative pi over 4, it's going to be equal to negative 1 because one of them is negative. So then tangent kind of looks like a cubic function here, just does this thing. And again, since it's periodic, it's going to do the same thing. Over and over. Okay, now cotangent, remember, is cosine x over sine x. So where is this going to be undefined? Well, this is going to be undefined wherever sine is equal to 0. So basically our asymptotes shift on this one, and instead of being at the pi over 2's, they're at the pi's. Okay. Now it's equal to 0 whenever cosine is equal to 0, because cosine is on top, right? So where's cosine equal to 0? Well, at pi over 2, negative pi over 2. And then it's equal to 1, it actually goes like this. Because if you think about what is at pi over 4, at pi over 4, cosine is positive and so is sine. So at pi over 4, they're both positive, so your tangent or your cotangent is positive. But then at pi over at 3 pi over 4, one of them is negative, so now we're going to have negative. So it's almost like a flip. It kind of flips and shifts over from the tangent. Okay, so what we need to remember from these is that the first 4, they have a period of 2 pi, which means it takes a full 2 pi for them to go through one rotation, right? So here it starts up, down, back to 0. It took us a full 2 pi to get there, right? Or up, down, back to 0, full 2 pi, right? This one, same thing, top, 0, min, 0, top. That took a full 2 pi to get there. Same here. A full 2 pi is right here, okay? Now the interesting thing about tangent and cotangent is they only have a period of pi. It only takes pi to get through one, right? Because this repeats again over and over, and it only goes, this goes from negative 2, or pi over 2 to pi over 2, which is just 1 pi, okay? All right, so we should be able to graph from the parent graphs, we should be able to then transform all of them. Now, I don't know how much of all of these stuff is on the calc test, AP calc test, but you've got to know your graphs of your trig functions, okay? So you should have all of those 6 trig functions by heart, and then we use transformations to transform them. And, you know, we talked about, in pre-calc, we talked about period and amplitude and all of these words, and that's the right words to use. But let's look at this as a transformation, just a straight transformation. Let's look at b. Now, is b inside the function or is it outside the function? Well, it's inside the function, right? Because the function is sine. Sine is the function, and b is inside. That means this is affecting our x values, and the c is also inside of our function, so this is affecting x values, okay? So it's going to screw with our x values, okay? And then you notice that a and d are outside the function, so it's going to mess with our y values, okay? So then we have to decide what are they going to do to those values, right? Okay, so remember c and d are shifts. They are going to shift them left or right or up or down. So since c messes with x values, it's going to shift it left or right. And remember that your x is a liar. So anytime you c plus c, it really means move left. Or it means move the opposite of what you would think, okay? Now d changes y values, so it's going to move up or down. So, and y doesn't lie, so positive d is going to move it up, negative d is going to move it down. Now b is going to affect x values again. So remember, x is a liar, so it looks like you're multiplying x values by that b value, but you don't. You actually divide all of your x values by that b value. And then your a is affecting y values, so it's going to multiply all your y values by that number. Okay, so that's kind of like the basic. If you can do a basic one, we can do basic transformations. But if you remember from pre-calc, these are the actual ways that it transforms things. B is going to change your period, because you know your period is goes like this, right? So if I change my period, now I've just divided all my x values by some number, right? Or I've multiplied all my x values by some number. Now a is going to change your amplitude. Now remember, here we've got some function, and I multiply all my y values. What's it do? It makes it taller, right? Taller and like further up and further down. So that makes total sense. C is a horizontal shift, or we called it a phase shift. It's just going left and right. A vertical shift goes up and down. Okay, let's see if we can get this in before, how much time? We got 3 minutes maybe. Okay, so without using the calculator, we're going to try to graph this. So the first thing I'm going to do is I'm going to graph my, my regular sine or cosine curve, because I just like to have that. So it goes max, 0, min, 0, max. So this is my regular cosine curve. Okay, so there's my regular cosine curve. And then what I look and I see there's no shifts, there's no adding or subtracting of any numbers. It has a 1/2 there multiplying by my x values, right? This is really the same as 1/2 times x. Okay, so what did that actually do? That's going to multiply all of my x values by 2, right? And so if my period is normally 2 pi, and I multiplied all my x values by 2, now I'm going to have a period of 4 pi. Okay, so I multiply all my x values by 2, so this one stays the same. This one goes here. This one goes there. There. Oh, pause that for a second. Okay, so I'm multiplying all my x values by 2, so that one is going to move over here. We're going to get through one cycle in 4 pi, so I'm going to end up back here. So I'm going to go max, 0, min, 0, max. That's the pattern of cosine, okay? Max, 0, min, 0, max, okay? And remember that basically what I think of is my period is split into 4 pieces, right? So it starts max, 0, min, 0, max. So like a fourth of my period, it does that, each of those. Okay, last but not least, that's all we've got time for right now in this video is this -5. So remember, that's going to multiply all of my y values by -5. So instead of being at +1, I'm going to be at -5, which if you remember, that negative just flips it over the x-axis. So then this one's going to go here. This one's going to be at positive 5. So again, this has just changed my amplitude, and it flipped it because of the negative.